People are supposed to be in the class that we're supposed to be, yes. If you can still, I don't know if you still can do the closed captioning and see it later, I don't know. And by the way, if there are questions, they'll pop up down here. Okay. So just click on them, and then I can answer it verbally. Okay, so more people coming in. And so we're good to go. We're recording. All right, so thank you guys for coming. Thank you guys for coming. I'm going to let the lady in here. Mr. Savage is actually in person here right now. Just give you a heads up. Yeah, look at that. Okay, so we're going to get going. All right. Okay, so today you guys get 2 birds and 1 stone. We're going to be doing 2 things. We're going to do live session, learn some stuff, as well as do the lab as well. So if you guys need the lab sheet, I do have them. They are printed out. I'll make sure that you guys get them in the class. For the people who are online, make sure that you print out. I did push it out to you. Just kidding. Apparently I printed them out and I don't know where they went. Looking for stuff. They're right here, right where I left them. Don't worry, don't stress. I'll tell you stress until you stress. Here you go. Here you go. Here you go. Yes, ma'am.
Which is 403?
What?
Which one is
403? This is 403. Yeah, sorry, they just needed this, but. Testing. Cool, good. There you go. Cool. All right. Do me a favor for all y'all know, all y'all people in the class. If someone walks in, do me a favor and here you go. There's nothing behind me. I thought we were there. If someone else pops in, make sure you let them know that they have that. Now doesn't mean that none of you guys have a DOR in depth. We're not going to get into that. But if you have a DOR in depth, glad that you showed up. Because if you have a DOR in depth and you don't sign into the paper, which I have over there, I'm going to check that and I'm going to write down the kids who did not show up and have a DOR in depth. They do 2 more times, you're going to drop from the school. So make sure you're here. It's kind of important that you're here. It's not like a a lot of people think I'm not an idle threat person, but if they tell me something happen, I will expect it to happen. And I just want you guys to be successful. I don't want the students to be here and have you guys get all F's and I don't tell them you're a successful teacher and you're not a successful student. I don't like that, okay? So make sure that you do well. So today what we're going to do is we're going to do the lab on cloud formation. Okay, so we're going to learn about a little bit of cloud formation and all that stuff, and as well as take care of these birds at the same time. What's up? Didn't do a lab on cloud. I wasn't needed in typo that came to take all the totally fine. Yeah, I did one last year like this, but it was totally fast. Oh, maybe you showed up on accident.
Okay, no, it's here.
Yeah. Yeah, and someone said it's hard to hear. Okay, I'm going to try the best I can with the whole hearing thing, because I have students in front of me as well as students online. And I'm going to go ahead and, can I turn that up? Okay, let me see if this is going to help. Someone brought up a point. Okay, is this helping at all? Perfect. Thank you very much for your assistance. Alright, so let's get going. We're breaking stuff down. We're gonna learn this stuff. Alright? Okay, so go to the next slide, please. Alright, so essential concepts. The essential concepts, by the way, people online, you're going to have to answer this question and turn it in and submit it through the Dropbox. People that are here, we're going to go through it together. Y'all get credit for showing up. You don't have to see anything to the Dropbox. You're awesome. Okay? You're awesome, too, that are at home, just a little No, they're just kidding. But no, let's go ahead and go through the essential concepts. Now, what I want to do is I want to break down the essential concepts and work that you understand. Because right now, this is what I read. Explain the differences in air temperature, amount of moisture, condensation nuclei, and pressure using data about geographic and topographic locations. Super scientific, boring, I don't know what it's saying, right? So let's break down some of the words. So the all right, so who knows what temperature is? Anyone? Anybody at all? Anybody?
Temperature is the air molecules, like when it's hot,
Just air molecules?
and gases,
Any molecule.
any molecule and gases that heat up with energy and get colder when it becomes thin, and with less energy and powers up together.
Those are, that's all correct. Not incorrect at all. All correct. There's more or less of the definition, more of the action due to definition. Anyone know?
Like hot and cold weather and not climate, rather than at the time hot and cold, warm, how hot it is.
Yeah, and then, so temperature is how hot, how cold it is. But basically, break it down.
It's the measurement of how fast molecules move.
Okay, let's let the man speak here. Let's let the man speak. What was it again?
The measurement of how fast molecules move.
That's what it is. It's the average kinetic energy of molecules in motion anywhere. In your body right now, there's molecules going all over the place, okay? Everywhere. They move around. You have a temperature, 98.6 degrees. Hey, if you have it less than that, way less, you're no longer here on the planet. If you have it way, way, way more, again, you're no longer here. Your enzymes don't. We're not getting the full biology of it, but you have a temperature. This room has a temperature. Right now, the temperature of this room is 76 degrees, which means based on that measure that Fahrenheit guy came up with, the average molecular kinetic energy in this room is 76 degrees. As they turn the heater on, all these molecules get all agitated anyway. We're a little faster. And they start bouncing around more. They start bouncing around more. Temperature goes up. That's what the temperature is. It's the average kinetic energy. Yeah.
Oh, is it good?
Yeah.
Oh, so it goes like this. Go here, and you can click out of that person, and then go here again.
Oh, okay.
Oh, average kinetic energy, it's a formula that we're not going to go into, but basically it just means the average movement of the molecules in the room. That's what it is.
That's why when the water's just sitting there, it's just boring. It just sits there. They're moving around, but you can't see them. But once you start putting a fire underneath it, they start boiling and moving around. That actually is the kinetic energy moving so much it starts to jump into the air. That's what evaporation is. All right, so we know temperature. Cool. Now, what is moisture? We're going through and getting the exact wordage of this thing so you understand. What is moisture? Really? Really? What is moisture? And y'all are looking at me like you have no idea what I'm talking about. You're killing me, guys. Anyone that doesn't have a green shirt on. Technically, sure that every color of blood is green.
I'm the only reason here.
Technically, you don't have to take it. Technically. You have every color above green, that's why it reflects, and that's why I see to throw it out there. So every color above green. So, you know. Not going to get that. What is moisture? When you think moisture, first thing pops your head.
Water.
Like, well, you guys.
The condensation of water.
Water. Water. Moisture is water. That's boom. Water where? Right now in the center. Right now, there's little hydrogen molecules with the two little oxygen molecules floating around this room right now. I can prove it. I don't have the stuff to prove it, but I can prove it. All I need is a cup with ice in it and set it on a desk. What happens? Ice melt. Got it. That was the outside of the glass.
Condensation.
Condensation, not from inside the glass. When I was a kid, I was not very smart. When I was a kid, I used to go, "Oh, Mom, the glass is leaking." My mom was like, "Oh, you're so stupid." Then I learned it didn't come from inside the glass. It came from the air on the outside. basically a game of place for all this water to kind of attach to, and then condensate, and then drip. Perfect. That leads to the next one. Condensation nuclei. Who knows what that is?
If you don't know moisture. If you don't know moisture, we're not going to know that.
Yeah. She's like, this is captain saying, obviously we don't know this right now. Okay, just so you know, condensation nuclei, I'll let you know what that is in a little bit. Okay, we'll go through it, we'll learn what that is. Okay, and then also pressure using data of geographic and topographic pressure. What's pressure? You have to pass this test. What's pressure? Not that. What's pressure? Anyone else has a green journal?
The amount of force exerted on an object.
Okay, let the man speak. Breathe it. Go. What do you say?
The amount of force exerted on an object.
Boom. Find something else. Okay, in this case, we're talking about air. Right now, there's air going like this. See, when you're not here, you don't get to see me hit children. See? This is exerting on them, all right? So what's happening is it's pushing against them. As it changes your body, it actually feels that different. That's why when you get in higher altitude, you feel weird and stuff like that. That's also why when you take your body and you go underwater, the pool is like 10 feet deep, it feels really weird. It's the exact same thing. Everything okay? Don't worry about him. He only wants to know rocks. Let's not worry about him. If he says that, just kick him out if you need to. I'll show you that easy. He wants to, he's going to let him out rocks this whole all right, so that's why you jump in the pool and you swim to the very bottom. It hurts your head, right? Your sinuses, because your sinuses have the biggest susceptibility to pressure change. So when you go down, it hurts. Same exact thing, just pressure on you. But now we're talking about is pressure on in a situation or in an area. Like if it's high pressure, molecules all together, or if it's low pressure. We're going to learn about the pumps and things like that. So next. Okay, so to do this, we're going to need a few things. We're going to need a water bottle, which I couldn't find one that's big, so I kind of use this. One is a big one, like, you know, like a 17-liter one, but it doesn't sell to me. And then we need to have, does anyone here have a lighter? Almost got me. Yeah, so we need fire. Yeah, we need to create something. Well, don't worry, we'll get to what that is in a second. And we also need a watch, but honestly, we don't really need a watch because they said you can only use this type of watch. I'm just kidding. You can use it. But we're not going to really get into the watch because we don't really need to know specifically what we're doing. I'll show you what we're going to do. Deal? All right, so we need these things. So when you're at home and you do this on your own, these are the 3 things that you need to get this done. If you have no fire, talk to the person that pays the bills inside the house. I highly recommend they'll help you with that. If not, I recommend using a softwood and a hardwood. You create a notch in the softwood. Then you create a divot. You move the dowel from the hotwood over it in a circular motion with your hands. Do that for about an hour. It'll get cold. You'll create fire that way. That's how you make fire in space. They wanted to pay attention. Just FYI, anything that you write on this, you can see it from the other class. If you say something I don't like, we're not going to be happy. Just be aware of that. I don't think you'll say anything. All right. Next. Okay, so, go back one. Okay, so this right here is what you have in front of you. So what we're going to do is we're going to kind of do the first part of the experiment. We're going to have a conversation about it, and we're going to sit there and stare at water basically. So I put 200 milliliters, close enough. I was going to do whatever I wanted, and one of the students told me you have to 200 milliliters. I was like, whatever, all right, I'll do it, I guess. So 200 milliliters in here. I've created an environment. Pressure is stable. I close this. The pressure is not going to change inside here. No, don't worry about it. Point stuff out. It's freaking out. There's something behind you. All right, so I put the water here, and what I'm going to do is I'm going to agitate the molecule. I'm creating an overall equilibrium weight on the inside. Good for me. Okay. Okay? And then I'm going to do this together. It'll be funny. We'll totally fun from the other. Okay, ready? What do you do? Ready? You see it? See it? See it? Okay. That's okay. What you basically see is going walk over a little bit of a cloud showing. A little like fog inside. So, on your very first line, it says, what happens when you add cold water? When you add cold water to the bottle, you shake it. What did you see when we actually did it? So explain to me in a sentence what you saw. What did you see? That's the question. By the way, if you're at home, you don't get to see it. Unfortunately, it's something super small, and I can't really show it. And the best I can is do maybe this. Best I can is maybe do this for you right now. It's right here. This is the water bottle. You put 200 milliliters. Shake it up and see if you can see it. Not very much. Come back to you on that. Okay, so now what I'm going to do is do a thing called a condensation nuclei. You saw that up there, right? Part of the nuclear flash. You didn't really go over it. This is the thing. Water doesn't just like to kind of hang out with each other. They need something to kind of make them hang out. They need something like dust. They need something like smoke, ash, salt, things like that. Anything else that's in the air, it can connect to and hang out with. And we'll see that in both this. I'll show you like a PowerPoint as well. So what I'm going to do is I'm going to basically, at home, again, get your parents in this. I'm creating a fire with a lighter. Lighting a piece of paper on fire. Okay, so I added smoke. Okay, I added something that it can attach to now. I added a little thing in there that the water can jump between them. So I do this, right? I have my high pressure. By the way, I have high pressure by squeezing this. Good. Create what? What do you see now? Five. Write that down. That's the second one. I added smoke to this one. Let's go ahead and jump on the video and see if I can get you to see this. So, high pressure, low pressure. I think you can actually see that. Good. All right. So that's what I did there. Now, what I'm going to do is I'm going to continue to kind of have a conversation while I'm warming up the water to a hot state. Okay. If you're crackling or something, it's just bring it down or up. Just water evaporating and crackling. All right. So at home, what's happening is I'm having the water warm up on a hot plate. Now, if you can't quite see it, I recommend coming in. All right, let's go.
Next one.
Next one. Thank you. Okay, bring up a cloudy cloud like front. Okay, so we already know this. We need water vapor. Okay, so we need water as a gas basically evaporating. We did that by agitating this in the air, whatever. But we need basically a change of conditions, like condensation from a gas basically to a liquid. That's what happens when little molecules hang on to one of those little like particles, dust, sand, whatever that's in, dust or pollen or whatever it is. And then what happens, we need a change in conditions. For example, we needed to go from one pressure into another because we need this hot air, or this air basically to start condensing, coming together. They create a critical mass, and then they go whoosh, and they cry all over us. Because that's what rain is. It's crying cloud. It's that. You send me cloud, make sure you help them with that. Next please.
Hello, okay, hi, after that kind of fog.
What is the cloud on the ground called? Fog. Fog. You know how it's in fog. funny. I'm all looking up, I need to like walking around and like doing like this. We're pretty good all right. Alright. So how does water vapor get into the air? Can you take away the water vapor get into the air? How does the water that we see, cool, you know, you jump in the pool, you're like, it's so fun. How does it come back into the air? Any questions other than people on the green? One of them is what? The evaporation. Does anyone know the other tricky one? Alright, so
another way that it goes out is via vapors and via the air, pushing the molecules. So, that would be good.
no, it was good guess. Good guess. Can you go and get the next slide on the thing? Alright, E stands for evaporation. Comes from the water directly, right? What does the P stand for? Oh, you don't know the answer, do you? Why did he need to be You're more than you're guessing right. The answer that was given by the A student in the back of the room is transfers. All right, they said to leave the. I want to see if I can leave the camera on. I guess I'll try it. Let's go like this, I guess. No, I don't like that. Nope, not leaving it on. One of the reasons is I have it facing towards the students, and I don't want that. So I recommend if you want to see me in person, like everyone else in the world, come see me in person at 8 or 9 o'clock, whatever your session is. All right, next slide, please. By the way, you want to know where from the plant the transpiration is. The answer is 21. Here's a leaf. Here's a leaf. Top of the leaf. Gotcha. They usually speak out the bottom of it. There's a little pores that happen in the prison. Don't need to know that, but it's just good enough. Just so you know, as moisture capacity increases, temperature also increases, you get the higher likelihood of having clouds, things like that. Typically, go ahead and next one. We're going to actually jump through these pretty quick, so you guys play out. Go back up one. Not that quick. So the water vapor layer will condense as it gets colder. Colder happens different ways. Either a cold front comes in, literally, this huge, like, invisible cloud, invisible, land mass, comes marching in the area with wood, high pressure. Get out of here. Once you go up there above them, yellow, and then they have to get up and get out of the way. Or the water, or the cloud can go up a mountain, and starts to condense as it goes higher up in elevation, and it also cools down the same way. Okay? Next. All right, just so you know, the major point on this slide, point out is the third one down. Dust, smoke, ash, salt particles in the air serve as a surface for water vapor to condense on. That's important. And once they all start kind of coming together and like hanging out, they start to cry because the clouds cry and there's too much moisture. Next. Okay, so these are different ways that smoke gets into the environment naturally. One of them is the volcano top left. One of them is the top right of forest fires. And just so you know, forest fires that are non-human created are good. We just don't like fires because they burn down our houses. But when we were around, fires would burn across these areas every few years. Why? Because it burns all the fat, and all the stuff that's dying. It creates the ash actually fertilizes the ground, creates a new crop. It's actually good for the environment to burn, for like forests to burn down, naturally burn down. It's good for them because it gets rid of all the old wood that's on the ground that the components haven't got to yet. Get rid of all that stuff, and then they grow again. They become bigger, stronger the next time. Next one here is pollution. Pollution's bad. I don't know how to put that, but typically pollution is not natural pollution. We do that because we're humans and like to destroy things. So what we do. That's what we do. We're the only animal on this planet that if you got rid of, the planet would be better off. Think about it. Pretty much in every situation or circumstance. The reason why there's a picture of the ocean there is because it's where I want to be right now. That's actually because those salts in this area will also create things to droplets to land on. All right, so this is what's going to happen. Basically, you have your water molecules on the right-hand side, or vapor molecules, and then you have your condensation nucleus. It's not a real magnet, okay? It's not a little magnet floating around like that. It's just a piece of sand, not sand, but like pollen, dust, things like that. Go ahead and hit next. What happens is it all starts to attract. Next. You see the sharp and move. Next. 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 There you go. See how they actually attracted? That was awesome. I know how to do it. The animation. Next. Alright. So basically those condense together, become liquid water, they kind of float around in the sky, they hang out with each other. It's too much, become big, huge clouds. Big, huge white clouds are just going to chill up there typically. Big, huge brown clouds, so they're going to have too much water and then you can start crying. And that's when you get the rain. The darker the clouds typically, the more the rain. The warmer it is outside typically, and if there's going to be a big rain, you'll get a higher chance of thunderstorms and lightning. Which are awesome, right? It does the job. Next. 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 Okay. Now, what I'm doing over here, okay, make sure. What I'm doing now for the ladies and gents at home is I am not the glass. Go a little water underground and bring the glass back. Actually, wait. Where's the feature? Where is the feature? Come here. You guys need to keep an eye on me. I don't know where I put stuff out. Where's it? Kill it, small. Where's the beaker? She's looking with her. I have to go for it out and do it. Hi, Ms. Delmer. Welcome to science class. By the way, everybody say anything closed caption, record it. Oh, just kidding this side. No, she loves me. She doesn't like fun. It's smart people. It's very helpful. Thank you. People wondering why you have a reason for that thing? Alright, so what I'm doing now again is I'm taking the hot water from the hot plate I put in the room, and I'm going to try to pour this into, yeah, I know, I'm totally pour this everywhere, but we're going to try to pour it. They just over his head there now. It's only boiling water. We'll probably see it thing. Okay. So I have a super hot water in there. I'm closing up the lid, creating an environment of constant pressure, and shaking it to allow for pressure to occur. And just so you guys know, you guys can feel this, I did. It became a lot harder to squeeze as soon as I started shaking. Because all the molecules started jumping against the side, creating a higher pressure in there. Shake, 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 squeeze, creating a high pressure, move to low pressure. Okay? So a little bit, basically. What you're seeing is a little cloud. Heavy cloud. Big cloud. Not much, but a little bit. Basically, just looks like a little fuzzy in there. So on your third line, what you're doing is you're looking at it with, just so you know, the one online, I'm not going to show you guys the video because really you won't be able to see anything this time, but I'll show you what happens when we add the smoke. Because we're adding what? What is the smoke adding to it? What's that? Those two words that sound cool together. What? What? What does it mean? What am I adding? What am I adding by adding smoke, dust, pollen, and all that stuff? What is that called? What was that called? I'll start with condensation. What's the second one? Thank you. Both of you guys together. Thanks, Mark. I'm glad you called it. All right. Put it in here. Smoke. Okay, so I added smoke to this. I'm shaking it around again. Again, smoke's gone. There's no smoke in here. It's gone. The water grabs a hold of it, okay? I need some high pressure. Shake, shake, shake. Low pressure. High pressure. Low pressure. High pressure. Low pressure. That's important.
What is the difference between high pressure and low pressure? Okay, people's in the internet land. High pressure, this is hot water with it. Low pressure. Hot, no, hot. So hopefully you saw that.
Alright, so what seems to be the major factor in getting clouds?
Low pressure.
Pressure and low pressure and
Condensing nuclei.
condensation nuclei. That is very important. Pretty much, you didn't really see one unless you got that. Next, please. When we go through, we're going to go kind of fast with slides here. Okay, condenses together. Good for us. Next. 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 Okay. What will force an air to rise? Will be a couple things. One is a warm mass kind of goes into a cold mass. The hot air has to rise above it, so it will actually get pushed above it. Like, go over it, and it'll make you go over the top. Or you'll have an air mass that will make its way and hit a mountain, like literally hit the mountain, and has to go over a mountain. It will condense as it goes up because the temperature changes as you go up in altitude. Next. Okay, there's a picture of when it goes up to a mountain. Last class, someone said they're going to Hawaii. Have you ever been to Hawaii? You ever been to Hawaii?
I've seen Hawaii, but no.
I've seen a movie about Hawaii, and I looked at Google Earth, and I put my little guy, and I set it on the street level, and I walked around and checked out. You can do that, by the way. So, what did you notice? What island were you on? Yeah, Hawaii. We got on Hawaii. No. Hawaii is like 7, whatever, smaller islands. Hawaii, Molokai, all around me all. Yeah, they got it. What did you notice above the mountain? Smoky and or cloudy. Some smoke probably, but cloudy. So what happens is you get rain on it.
Yeah.
It's weird. And so he's sitting there, enjoying the Coca-Cola in your hand, drinking your water. And you sit there, and all of a sudden, this hot, beautiful, clear day, and all of a sudden, it's pouring rain on you. You're all, what the heck just happened? Why is it raining? Well, what happens is sometimes air pressure will change because it's in an ocean, and the cloud will then come flying down off the mountain, come down over you, pour itself rain, and then it's warm rain, it's like 90-degree rain, it's weird. And then all of a sudden, it just gets pulled right back up to the mountain and it goes away within like 5 minutes. Weird, you keep walking, it's like, and rain, and then you keep walking, like, and no rain, you just keep walking. It's really kind of amazing. Both times when I went to Hawaii once, when I did that, saw that, and then when I went to the Caribbean, it was the exact same thing. All right, next.
I think the laptop is back.
Yeah. No, there's no battery.
Thank you for giving a heads up.
There you go. Sorry, guys. Just so you guys know, apparently you have to plug your computer in.
Just FYI, that's just something y'all should know. It died like really quick. That's weird. Go back for me, please. I'll have to check the recording. So this is what happens, just so you know, when you get moisture from where the sea or the ocean is going and hitting at higher altitude, it creates all this rain on this side of the mountain, goes to the other side, and you basically do not have as much rain from the other side. That's why you have to dry here in Elsinore, because Orange County jacked all your water. It is. Water is needed. I drink it every few often, and it keeps me alive if I don't have to. I like it. I like air more. Air is more. I like air more.
So 2 minutes without air, 2 days without water, 2 weeks without food.
You can lose for
Survival stuff. No.
just 4 days without,
People have died waiting for water. Depends on what you're doing.
but that means 4 days without water, 4 minutes without air, and then
Okay, oh my God, that's all right. I used to, as a kid, just like hold my breath for how long I feel for. So like the longest I ever held my breath was 1 minute and 45 seconds. And then I drank water and then I passed out. So my mom, I woke up my mom. All right, we good? Can everyone hear me here? Give me a smiley face if you can hear me on the internet. Perfect. I don't know if the recording stops because I have another moderator in here. So I think we're good. So we'll keep going here. Next, please. 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 Okay. This right here is when, again, you get a cold front kind of making it in the area and making the warm air go above it. You get basically the warm air pushing you going straight up. Get those big, huge clouds. Those ones you see in the distance, like, you know, right where it's like crazy rain here. It typically doesn't happen, right? It stays pretty warm here, then at night it starts to cool down and the rain comes in. So it allows for the condensation to sort of pull into the area. Your warm front still keeps it away because you're still a desert out there. Yeah. So this one talks about a gradual one, or kind of gradually makes its way up. This is what you see in the marine layer on the ocean and all that stuff. This is what you see. Next. Stationary fronts, real quick, is that there's two fronts that don't basically go over each other. They're just next to each other, kind of hanging out and waving at each other as they're walking by. Okay, typically have any clouds, rain, things like that. Next. This is going to let me do this, but if you ever want to watch clouds go across the United States, Google it. Cool. Next. That's what you see in the distance. In this area right here where these people are at, it's probably a warm front, keeping out those clouds away. And there's a cold front out there. And the cold fronts, if you watch, if you don't do this anymore, but if you just kind of watch the clouds, you can see which way they're moving. Just sit there for a second and see the clouds moving. You know which way the wind's blowing up there, as well as if it's coming towards you. You know that you are in an area that's warm. Thanks to the cold is probably the rain that's coming in. Stuff you need to learn, I guess, if you ever don't have the internet. She's like, don't tell me about a video like that. I'm like, really? That's never going to exist. I'm supposed to be on Instagram, Facebook, MySpace, Twitter, LinkedIn, whatever else. All of the rest of them. It's for older people that have jobs and professions. Yeah, I never had one because my face was like that, so you ever go on there. But then I had a Facebook. I don't think anyone else. I had a Facebook. I got it because college students only used it to communicate at one time. So I got it back in 2002 or something. I was right when I started my account. I don't think it was about 22. And yeah, I don't want any of that stuff. So I'm okay with the internet going away. I don't do LinkedIn, so I got the job. I might put my resume anymore. Next. Okay, so let's see if I'm able to do this. The people on the internet, one second here. Okay, so the people on the internet, you can type in that code basically. You won't be able to copy and paste the way Illuminate works. It doesn't integrate very well. So you guys go ahead and I'll leave that on for a second for you to write that down. Let me see if I'm able to quickly bring it up real quick. And I think it might actually be up here. Actually, I just got it, so I'll go ahead and I put it in the chat box. Go ahead and watch that video and go ahead and put the essential question in the class for your credit for today. You still need to complete out your lab to be able to get credit, and you can drop that in the Dropbox into the lab as well. So go ahead and have a good rest of the day and get out of here.